I'm Amalia Ross, and I'm doing problem number 69. So, this is the problem that we're given. If 70 milliliters of nitrogen gas reacts with 45 milliliters of oxygen gas, what is the volume of N2O3 produced? Assume all gases are at the same temperature and pressure. So this is the equation they give us. It's N2 gas plus O2 gas yields N2O3 gas. Okay, so we're going to start out by balancing the equation. So we're going to start out with an easy number, which is O. And so the only thing that's in common with the 2 and the 3 is if you multiply them together, you get 6. So we're going to multiply this by 3 and multiply this by 2. So now we have 6 O's on either side of the equation. And then now we have 4 N's. So to get 4 N's on this side, we're going to multiply this by 2. Okay, we're all balanced now. Okay, so next we're going to find the atomic weight of each element. So the atomic weight of nitrogen is 14. And there are 4 of them, so your total is 56. And then oxygen is 16, and its atomic weight, and there's 6 of them, so multiply by 6, and then you get 96. So each of these, this is the atomic weight of it, 56 and 96. And that is equal to 152. Okay, so now we have all that set. We are going to calculate the mass of the product that can be produced from the first reactant. So for the first reactant, they give us 70 milliliters of nitrogen gas. So 70 milliliters of N2 times, you want to find the ratio of oxygen to nitrogen. So it's 3 milliliters O2 over 2 milliliters of N2. And then that is equal to 105 milliliters of N2O3. So, but limiting reactant is you need to find the smallest number of the volume because this is a volume problem. So, next problem. We're going to, and it gives you, it's 45 milliliters of oxygen gas. So it is 45 and then you're going to find the ratio of N2O3 to O2. So it's, 2 milliliters of N2O3 over 3 milliliters of O2. And that is equal to 30 milliliters of N2O3. And that is our answer because it is the smallest number when you plug in all the numbers and everything. So that is our final answer, 30 milliliters of N2O3. And thank you for watching.
Hi guys, my name is Noor Noelati, and I will be doing number 63. The question is, if 1.0 grams of magnesium hydroxide reacts with 0.605 grams of sulfuric acid, what is the mass of magnesium sulfate produced? This is the equation we have, and it's not balanced. So as you look, the thing that will balance it out is if I would add a 2 right next a 2 here, and then it would be balanced. So we're gonna go ahead and figure out how to do this. So we're gonna start out with 1.00 grams of MgOH 2 times 1 mole of MgOH2 over the mass, or what this is. So Mg is 24.31, O is 32, and H is 2.01, gives me 58.32 MgOH2. Then I'm going to times this because I'm trying to find out magnesium sulfate, which is this right here. So like I said, Mg is 24.31, S would be 32.07, and O is 64. Gives me 120.38 MgSO4 over 1 mole of MgOH2. So this cancels out with this cancels out with this, and this with this. This gives me 2.06 grams of MgSO4. So we can say that we produce 2.06 grams of magnesium sulfate, and MgOH2 is limiting. Now, the last step is to find out the mass. We're going to use 0.605 grams of H2SO4 times, times 1 mole of H2SO4 over, again, like we found out what this was, and this is going to be 98.08 grams of H2SO4 times 120.38 grams of MgSO4 over 1 mole of H2SO4. We cancel out again, and our answer is 0.742 grams of MgSO4. And that is our answer. Thank you very much.
Okay, I'm Brianna, and my problem is problem number 59. And basically it's asking for if 40 grams of molten iron oxide reacts with 10 grams of magnesium, what is the mass of iron produced, which is right here. And the products are iron and magnesium oxide. So we're not looking for magnesium oxide, we're looking for iron. So the two limiting reactants, well, one of them is going to be this one or this one. So we have to make two equations to find out which one is the limiting reactant. So we're going to start with 40 grams of iron oxide. Okay, and then we're going to times that. We're going to make one bridge. We're going to times it by 1 mole of iron oxide over the molar mass, and the molar mass is, let's see, 55.85, which is iron, and 16, which is oxygen, and that equals 71.85 grams. And then we're going to make a second bridge, and this will be the molar mass of iron, which is what we're trying to convert this to, so it'll be 55.85 grams of iron, and then that's going to be over 1 mole of Fe. And so if you calculate this out, let's see, so we do 40 divided by 71.85, and then that times 55.85, and once it'll equal grams, and what it's going to equal is 31.09 grams of iron. And so that's what you'll get if you use iron oxide. And then the second equation is going to be 10.0 grams of, let's see, magnesium. And then basically we'll do the same thing but with magnesium. So it's going to be 1 mole of magnesium over the molar mass, which is just 24.31 grams of magnesium. And then we'll times that, the second bridge, times, it'll be the second part of the first one, basically, because we're still looking for iron, so it's 55.85 grams of iron over 1 mole of iron. And so if we do this out, it'll basically be 10 divided by 24.31 times 55.85. And this is going to give us 22.97. We can round that to 23 grams of iron. And so this one will give you more iron. So 31.09. This one's going to give you less, which is 23 grams of iron. So obviously this one, magnesium is going to be the limiting reactant because it gives you less amount of iron.